Hello, everyone. Today, we will learn about optical communication. Optical communication, also known as a fiber optic communication. Optical communication has made revolution in telecommunication industry. Enable to make telecommunication to link in a great distance with minimum losses. Lastly, can enable higher data rates to be accommodates.
What is the element of optical communication?
The element of optical communication is 1. Input signal. 2. Transmitter. 3. Transmission channel. 4. Receiver. 5. Output signal.
Can you explain about the element in optical communication?
Course. Let me explain. Input signal is using the electrical signal as an input signal. Transmitter is a device that will convert the electrical signal into optical signal. Transmitter consists of the driver circuit that function to drive the light source. Light source to convert electrical signal to an optical signal. And fiber fly lead to connect optical signal to optical fiber. Transmission channel is a bit different between transmission channel communication system. Do not confuse, let me explain one by one. Transmission channel consists of a cable that will provides mechanical and environmental protection to the optical fiber. Optical splice used to permanently join two individual optical fiber. Optical connector are for temporary non-fixed joints between two optical fiber. Optical coupler or splitter used to provide signal to other device. Repeater or regenerator to convert the optical signal into electrical signal using optical receiver. Electronic circuit used to reshape and amplified as it gets attenuated and distorted. Signal will convert back into the optical signal using optical transmitter. Receiver convert the sight signal into electrical signal. The optical signal will be applied to the optical receiver. Receiver will consist of photodetector, amplifier and signal restorer. Photodetector will convert the optical signal into electrical signal. Amplifier and signal restorer are used to improve the signal. The output signal is an electrical signal. Last but not least, the fiber optic. Fiber optic is a long strand of glass or plastic fiber used to transfer signal in a form of light from a point to another point. There was two types of propagation modes, which is single mode and multi-mode. These two types has a different performance that will affect to attenuation and dispersion. But the single mode is better in the performance at highest cost. Besides that, types of mode are depends on dimension of the cable and the variation of the indices of refraction at both core and cladding across the cross section. Single mode are using single mode optical fiber, while multi-mode are using multi-mode optical fiber. Now, let me explain what is the difference between single mode and multi-mode. Let me explain about the single mode first. In single mode, the diameter of the core is fairly small relative to the cladding. Light signal will move in one line or single line to travel in fiber optic. Single mode fiber optic cable is fabricated from the glass. So, the single mode fiber optic is high cost to develop a single mode used in the wide area because it can go all the way up to 100 kilometers. Lastly, single mode fiber optic are mostly used as a local area network. Next is multi-mode. There was two types of multi-mode, which is multi-mode step index and multi-mode graded index. The diameter of the core are fairly large relative to the cladding. Besides that, multi-mode is high risk in the attenuated and Dispersion. Multimode step index, having a higher attenuation, and time dispersion. The costs are not too high than the single mode. The ideal length, only 5 kilometers. Multimodes, fabricated from the glass, plastic or pieces. Next, multimode graded index. It's having a similar characteristic with multimode step index. This multimode also have some attenuation and time dispersion. The costs are more cheaper and more popular in premise data communication applications. Losses in optical communication. Basically, there were a few types of losses that come from the element and fiber optic. When the light through an optical fiber, a small percentage of light lost through different mechanisms. Number 1 is attenuation. Attenuation are caused by passive media components, such as cables, cable splice, and connector. Although attenuation is significantly lower for optical fiber than for other media, it still occurs in both multimode and single-mode transmission. An efficient optical data link must have enough light to overcome the attenuation. Second is absorption. Absorption of light occurs due to imperfections of the atomic structure, such as missing molecules and a high-density cluster of atoms. Third is scattering. Scattering is known as a wavelength-dependent loss that occurs inside the fiber. The disordered structure of glass will make some variation in the refractive index inside the fiber. If light passed through the atoms in fiber, a portion of light is scattered. Fourth is radiative loss. Radiative loss occurs in fiber due to bending of finite radius curvature in optical fiber. Basically, there were two types of radiative loss, which are macroscopic bends and microscopic bends. Macroscopic bends. If the radius of the core is large, it may cause large curvature, where fiber cables turn at the corner. Besides that, light will escape from the fiber by the corner. Next, microscopic bends. Microbends losses are caused due to microbends inside the fiber. Microbends appear due to non-uniform pressures created during cabling or manufacturing. Lastly, it will lead to loss the light by leakage through fiber. Fifth, distortion and dispersion. The optical signal become increasingly distorted as it travel along a fiber. Distortion is due to dispersion effort. Dispersion. Dispersion occurs when the optical signal, or pulse, spread as it propagates through the fiber. Output signal is wider than input signal due to dispersion effect. The pulse dispersion will come in three ways, which is intermodal dispersion, material dispersion, and wave-guided dispersion. Intermodal dispersion. The intermodal will occurs when more than one mode is through the fiber. It will make a different wavelength and time to propagate through fiber. The signal will be dispersed in all possible paths through the core and make it in different modes. Next, material dispersion or chromatic dispersion. The dispersion occurs due to different wavelengths, which is traveling at a different speed. The material dispersion can be reduced at certain wavelength. For example, when light wavelength is more than 0, it will become faster. Lastly, wave-guided dispersion. It happens due to the guiding property of the fiber and due to the different angles at the core cladding interface of the fiber.